Match problem 4 is another double integral problem. We're given the information in a slightly different way. We're told to evaluate this double integral of the function 2x minus y dA over this region R. Now there are a couple of things I need to change here. X should actually be bounded between -1 and 5, and y should be bounded between 2 and 4. That's +2, +4. So this is just a different way of communicating the same information. The idea here is that we want to integrate from -1 to 5, integrate from 2 to 4, our function 2x minus y dy dx. Now again, keep in mind we could have set it up in the opposite order. We could have first integrated with respect to x and then with respect to y, but we'll evaluate it this way. So we'll make this kind of mental note that what we're doing first is integrating this or completing this interior integral. So 2x is treated as a constant in this case, and then integrating with respect to y means we multiply by y minus y squared over 2, and then we'll evaluate this expression from y equals 2 to y equals 4. So this will give us 2x times 4 minus 4 squared over 2 So that's our first expression, our expression evaluated at 4, and then we'll subtract our expression evaluated at 2, which will be 2x times 2 minus 2 squared divided by 2. So this will give us 8x minus 8 minus 4x plus 2, or 4x minus 6 when we simplify and combine those like terms. So now what we have is this interior result. We know that that's 4x minus 6. So now we can integrate from -1 to 5 this interior function, or that interior integral that we evaluated to be 4x minus 6 dx. So first we worked that interior integral, now we're working this outer integral, which is with respect to x. So integrating with respect to x will give us 4 times x squared over 2 minus 6x. And then we're going to evaluate this from x equals -1 to x equals 5, which will give us 2 times 5 squared minus 6 times 5. And then we'll subtract, evaluating that exact same expression at -1. So that'll be 2 times -1 squared minus 6 times -1. Which will give us 50 minus 30 minus 2 minus 6 for a final result of 12. So this was completing the double integral by first integrating with respect to y and then with respect to x. The problem asks us to complete this integral both ways. I'm going to leave the second part for you to try and verify, make sure you could come to the same result. So we would integrate from 2 to 4 and then from -1 to 5, the exact same function, 2x minus y. In this case, first integrating with respect to x and then integrating with respect to y. And you should be able to evaluate that and come to the exact same result. So I'll leave that one as practice. The problem is going to be relatively similar, again, except that we're just switching the order of the variables that we integrate with respect to.